Hello everybody and welcome back. We're looking now at question number 2 on the 2004 Euclid contest. That's the scholarship contest. So let's have a look. See, question number 2, hopefully you've at least given it a read through. More importantly, I would hope that you have actually tried this question, even if you think it's an easy one. Just like question number 1, we've got light bulb written part. However, we will still be writing a little bit of explanation for these light bulbs, even though we only need the final answer. We'll still be writing a bit of explanation. That way, if we screw up, we can get some part marks. Okay. So, A horizontal line has the same y-intercept as the line 3x minus y equals 6. What is the equation of this horizontal line? Okay. So I think this is a perfect example of why you might want to write down a little bit of what you're doing, because I think if you go through this question very quickly, you might say something like y equals 6 off the top of your head, and I think if that's not correct, I think it's going to be y equals negative 6. Anyway, I'm going to rearrange this equation into y-intercept form so that I can see, well, what is the y-intercept? Okay, so, oops, forgot to change my color. So we want the line 3x minus y equals 6. If I want it in y-intercept form, I want y equals mx plus b. So I'm going to bring the y over to the other side and the 6 over to the left-hand side. The signs change when we do that, and I can see I have a y-intercept of negative 6. So I just draw the teensiest of pictures. We're passing through negative 6. Let's say that's about here. And another point, just from observation, would be 2 here. So this is the line that we're currently looking at, and they want the equation of a horizontal line. So that's a constant line that goes through the same y-intercept. So these horizontal lines are always of the form y equals, just like if you had a vertical line, those are always of the form x equals, like x equals 4, that sort of thing. Okay. So y equals, well, what's that y value? It's the same y value everywhere. So it's the same y value here at negative 6. So y equals negative 6 is the horizontal line. Okay. But if you tried to quickly rearrange that in your head, you might have said 6, and that would have been a very bad answer indeed. Okay, so that's A part, not too difficult yet. B, in the diagram, line A has equation y equals 2x. Line B is obtained by reflecting line A in the y-axis. Okay, so now our brain starts thinking maybe what's an equation for line B, because they gave us one for line A, and line B reflected in the y-axis. How does that work? That's the sort of thing that should be popping into our head. Line C is perpendicular to line B. What is the slope of line C? Okay. So I'm going to flip the page and draw myself a bigger picture here. Bigger picture that I can mark up. I'll color code these guys. So we have y equals 2x here. That's line A. Then we have our good friend line B. It's the same thing but reflected. And then we have line C, which we're just told is perpendicular, although I think their picture goes through the origin. Not that that's important. And so he'll be perpendicular. So there's our line C. Okay. So what are we to do? Well, if I knew the slope for line B, if line B has a slope of m, we usually write m for the slope. Then line C, all perpendicular lines have the same slope, and we can obtain that slope in quite a simple way. It's the negative reciprocal. So if B had a slope of negative 1, C would have a slope of negative 1 over negative 1, which is 1. If B had a slope of 5, line C would have a slope of -1 over 5. That's the sort of thing. And this is always true. And it's just a nice little fact that we can state. And it helps explain what we're doing and why we're doing it. Didn't take us that long to write it out. So now the hunt begins. What is the slope of line B? Because once I have that, we're basically done. Okay. So if I imagine a point x, y here, which is really x, 2x, based on the equation for what y is, and I reflect it in the not the x-axis, the y-axis, it's going to be the same absolute distance between these points, and they're going to have the same height. So this point here will have height 2x. But what's its x-coordinate? And it would be sort of this 2x over here. It's going to get confusing if I do that. So I think what I'm actually going to do is just talk about specific points with numbers in them. So I could have 2 and 4 here, and I could do the same thing up here with, say, 3 and 6, so we can better understand what's going on. If I reflect, I keep the same height, and I've got to be the same distance. It's like if we got a mirror here, the y-axis is sort of like a mirror. If we get close to the mirror, our reflection appears to get close to the mirror. We stay the same distance away. But now this will be not over 2, it'll be over -2. So -2, 4 is our coordinate. And up here, we reflect this point, the point 3, 6. It's again going to have the same height, but now the x-coordinate is negative. Okay. So this is enough information. We can even say that by reflecting points 2, 4 and 3, 6 to points -2, 4 and -3, 6. We can find the slope of B. Okay? It's going to be rise over run. So what's the rise? Well, it's the difference in y coordinates over the run, the difference in corresponding x coordinates. You have to make sure they're lined up properly. 2 and the -3 minus -2, that's the same as -3 plus 2. So you will get a -2. Okay? So we could either calculate that as we did, rise over run, showing our work, or it's not actually that hard if you have some experience with lines. Like if you're in grade 9, you just learn what lines are and you're writing Euclid. Absolutely, rise over run, go with what you know. Be able to explain things. But if you're experienced, if you're in grade 12, you've seen a bunch of these line questions before because you've practiced other Euclids, that sort of thing. If you know how reflection works in the y-axis, that the slope just becomes negative, go for it. Absolutely go for it. It's a light bulb question. No one's forcing you to do it one way or the other. Okay? And that's the sort of thing that you pick up. Now, if you're someone watching in grade 9, maybe you'll know, oh, reflecting the y-axis, it does just make the slope negative. And that's fine. And that's something you can take for a future light bulb question. But that's the slope of B. So now, as we already stated, C has a slope of -1 over m, so -1 over -2, which is 1/2. And that fits with their picture. It was going up and to the right, so it should have a positive slope. Just like the -2 fits with our picture for B, because it's going down and to the right. That should be a negative slope. So I might put a little box on it to emphasize that this is the slope and we've got it. Double check. C perpendicular to lines. What is the slope of line C? Great, we're doing fine there. All right. So one more part to go. That's 2C, and this is the one where we do have to take care to what we're writing because we are judged on how elegantly we do it and that sort of thing. And they're not particularly picky. They mostly have a checklist of did they do this, did they do this, did they do this, did they mention this theorem, that sort of thing. Okay. So 3 squares, each of side length 1, are drawn side by side in the first quadrant as shown. Lines are drawn from the origin to P and origin to Q. Okay. So P looks like he has coordinates 2, 1. Q has coordinates 3, 1. Determine, with explanation, the length of AB. Ooh, okay. So, well, I think probably the quickest way to do this, I think you might be able to do it by similar triangles, although I really don't care to do that. I think the easiest thing to do is probably work out the equations of the line OP and OQ, and then both A and B have x coordinate of 1, so that would tell us the y coordinates, and it's the difference of their y coordinates that is going to be the length. And we just need to explain all that, show what we're doing at each step. For example, both the lines OP and OQ pass through the origin, so they're going to have the 0 as their y-intercept, and that might make things a little easier for us. Okay, so let's get to it. I'm going to do, as always, draw myself a picture. If I can draw, I could draw it down there, but then I wouldn't be able to refer to it quite easily, so we'll flip the page. We'll try and make these squares at least somewhat similar. Q, P, and then we've got O to P, O to Q. That's not actually that bad. 1, 2, 3, and then we had a height of 1 here. And we have the points that we're interested in. I think A is below B, although it really doesn't matter because we're dealing with length, so whatever we do, we're just going to have an absolute value sort of thing. So there's sort of two ways you can go about doing this. You can just start doing calculations and hope that whoever's marking will jump onto your sort of logic train, and that's fine. Because, well, one, they have a list of different possible solutions, and they have the people who mark these things, or at least set up the marking schemes, have really sat down and thought, what are the possible ways to do this? And every once in a while, there's one that we haven't thought of, or that they haven't thought of. But for the most part, if you're coming up with a way of doing it, likely they've seen it. Likely it's been anticipated. So you're welcome to just start computing lines, and somebody will say, oh, okay, they're doing the computing the line thing. But it doesn't hurt to explain what you're doing, or why you're doing it. Okay, so you might start by saying, the length AB can be calculated, since they have the same x-coordinate, the length can be calculated by the difference in their y-coordinates. To find these y-coordinates, I will find the equations of the line OP and OQ, and then set x equal to 0, x equal to 1. Okay? It doesn't hurt to explain what you're doing. Okay? That way, if you happen to have thought of one of the solutions that they didn't have in the marking scheme, people know what you're doing, and it's very clear from the get-go. No one will be confused. Your people will be marked quickly and correctly. Okay, so I might say something like that. Since A and B have x-coordinate 1, their distance apart can be determined by the difference in their y-coordinates. Okay. To find these y-coordinates, we'll find equations for OP and OQ, and then let x equal 1, because we already observed they have the same x-coordinate of 1. And that'll get us the y-coordinates, and that'll be fine. Okay, so we've got our plan of attack. PE is at 2, 1. Slope of OP, that's rise over run So that'd be 1 minus 0 over 2 minus 0, 1/2. And the y-intercept of OP is O, so it's 0. So the equation for OP, or an equation, is 1/2 x plus 0, or really just 1/2 x. No need to add the plus 0, it's ultimately meaningless. Okay. So now we can do the same thing for Q. Q is at 3, 1, because we go 3 over and up 1. Slope of OQ is equal to rise, which is 1, 1 minus 0 over 3 minus 0, or 1/3. The y-intercept of OQ is also 0. Both of them pass through the origin. So OQ has the equation of 1/3 x. And now I do want to be correct in my labeling, so B is on OP and A is on OQ. So B has coordinates 1 and then 1/2 of 1, or 1 and 1/2. A has coordinates. We plug 1 into the equation for OQ, which is 1/3 of x. And now I don't need to explain where I'm getting the distance from, because I did that at the start. So the length of AB is just 1/2 minus 1/3. I explained why all I need to do is take the y coordinates. And this, if you need to get out your calculator, if you need to find a common denominator, that's fine too. But we ultimately get an answer of 1/6. But we have explained ourselves, whereas just writing down 1/6 might get you a mark. Sometimes it doesn't. Certainly for harder questions, it does not get you the marks, because you could have just guessed or looked at someone else's paper. Although for an easy question like this, if you've just put the 1/6, you probably would have gotten at least 1 out of maybe 5 marks, or maybe out of 4, that sort of thing. But why not explain? You get full marks when you explain. Okay. So, that's it for question number 2. We got question 3 coming up, and that looks like it's going to have some arithmetic sequences, but we'll deal with that in the next video. So thank you for watching.